Hello, my name is Daniel Oyoka, and I'll be walking through my paper review results. And the title of the paper that I reviewed is Towards a Robust Diagnosis of COVID-19 Using Visual Self-Attention Transformer. And uh, and for the group project that we're working on is all about explainable machine vision techniques for fish disease detection. Well, the keywords encountered in the paper that I reviewed is the ensemble and convolution neural network classifiers, the vision transformers, and the cross-compass validation, and we shall look at each in details later on. Uh, and so the authors focused on apply the application domain focused on to by the authors was basically diagnosis of COVID-19 using CT scan images. CT stands for computed tomography, and we shall well, the computational problem that I was able to identify from the paper, first of all, was unavailability of large level image dataset required by most, maybe let's say the CNN module for them to be able to train. And in such domains as health, like when it comes to diagnosis of diseases, it's very hard to get label data sets that can be used for that. And so they saw to it that there was need for them to come up with modules such as the self attention transformer, which is able to exploit the unlabeled data sets so as to by pre unlabeled data sets by pre-training so as to make predictions accordingly. And the other is power generalization by deep learning based techniques. So as these CNN, for example, modules require a very big data set for training. So, and in most cases, coming up with such data sets is really cumbersome and very impossible at the time. So, for modules like the self-attention, users are able to use the little data sets that are available to make predictions. And lastly, the computational problem that I identify is that CNN modules require integrating global relationships among pixels, and for to be able to mitigate such a problem, there is the authors propose the vision transform, which uses self-attention mechanism for modeling pixel dependencies among pixels so as to uh, classify these images into different, let's say maybe infected or not infected by COVID-19. And so that's what I identified as a competition problem. So for the next, well, the modules used, authors used three different categories of modules: the assemble module classifiers, and CNN classifiers, and lastly, the vision transformer approach. The assemble module included different modules, and these are the gradient boost classifier, voting based classifier, and the other boost classifier. The gradient boost classifier, this works on the principle of combining multiple weaker learners to form a very stronger one, and such weaker learners are the decision trees, as so as to come up with a very strong and accurate module. And for the voting based classifier, this ensembles multiple independent classifiers with the final prediction being of the majority vote, and this enhances the robustness, but requires diverse base classifiers to be effective. And for the other boost classifier, this is very similar to the gradient boost classifier, and for it, it involves assigning weights to training examples of data and focuses on subsequent instances of learners on the on previously misclassified uh, data. And for the VGG16, which is an example of a CNN module, this is the pre-trained deep learning approach commonly used for image classification, and it especially extracts high-level features from images suitable for classification. The same applies to the ResNet 50. And lastly, for the Inception V3, it's also part of the deep learning modules, and it's and and it's able to give efficiency when it comes to classification as well. And lastly, the vision transformer approach. This initially was used for natural language processing, but eventually uh, there has been trend like it has been now used for classification of images it involves segmenting images into patches, then analyzing the dependencies between these patches. And we shall look into this in details in the next slide. Well, for this slide, it shows how vision transform approach works, and it involves getting CT scan images, and these images first of all have to be pre-processed by resizing and normalizing them to a standard format, and later on they are supposed to be divided into squares or grids to create what is called patches. So you see, for this case here, you see here, all these are patches, and of which these patches are supposed now to be converted into vector representation by the embedding layer. The vector representation enables the module to, to process the visual information in these different patches. And later on, these vector patches are, are, are pushed onto the transformer encoder. And this is, you can say basically, this is the core of this kind of architecture. And this, for this particular case, the transformer embedder this uses the self-attention mechanism to analyze the relationship between different patches, and this allows the model to capture long-range dependencies among these patches and global features within these images, which are very crucial for identifying patterns indicative of COVID-19 in CT scan images. And lastly, the information got from here is processed the processing information got from the transformer encoder is therefore passed on to another additional, maybe let's say a neural network, which is able to classify these uh, these images to show that maybe somebody had COVID-19 or this person didn't have COVID-19. Well, maybe the advantage of this VIT is that they hold a strong global context, which means they're very excellent when it comes to capturing overall context of images which are important for identifying subtle abnormalities in CT scan images. And for the disadvantages of VIT, like maybe it's computationally costful, since it requires a very big number of data to carry out this whole system to be able to classify images. And also it involves a black box maybe kind of thing. It's very hard to know which features did the model based on to come up with this prediction. So it's very hard to interpret it, in other words. So for the next slide, I'll be trying to visualize the images what's of what the VIT basically comes up with. You can see here that we have a CT scan image, which is right here to the left top, and you see that we see the attention map, which is also sometimes called as the heat map of areas which are indicative maybe that person is infected by COVID-19, and you can see from this the bottom right image. So this is generally the visualization of a person who is infected by COVID-19. And for a person who's not infected, you can see still the attention map, heat map here still indicates these regions, which may be show if this which show that the person may be healthy and can't be classified as an infected person. Okay. The module evaluation metrics are applied by the author. They use three, basically the recall, precision, and accuracy, which is going to be talked into details much later. Well, when it comes to model analysis, the strength and weakness of the various modules, for the VIT, as I discussed previously, its advantage is that it has a stronger global context, and the disadvantage is that it's computationally costful and also very hard to interpret it. And you can see here when this module was applied on a Brazilian dataset, this is what was obtained. This is the accuracy levels, and for the the green curve shows that the precision recall curve of the class is 1, and the blue one is the precision recall curve of class 0, and the dotted one is just a micro average precision recall curve under that area. So when this same module was applied on a HAS19 dataset using maybe a small patch size of 10, let's say this is how it came to be. Like this is what happened according to the graph here, whereby when the patch size was increased to 12, you can see that the accuracy increased highly. And for the ensemble classifier on a HAS19 dataset, these are the performances of various modules of the ensemble classifier, the other boost. This is how the graph came about, and you can see that this obtained maybe the least accuracy among all the rest, and this got accuracy of relatively higher than the other boost. And finally, the voting boost classifier, this this showed a very very high accuracy as compared to the rest of the classifiers for the ensemble classifier. And when it came for the ensemble classifier in the Brazilian dataset, it generated the first two, the other boost classifier and the gradient boost classifier. Uh, they represented a very good accuracy compared to the voting based classifier on the same dataset. And and when it came to a model analysis for deep learning classifiers on HAS19 dataset, you can see that well, for the VGGS 16 module, the accuracy is greatly very high, and for the Inceptive V3 is relatively lower than that of the VGG 16. And this one, the ResNet model accuracy, is also high, but actually it's very high than the Inceptive V3 model. So lastly, when these deep learning classifiers were used on a Brazilian dataset, and this is what was obtained. The curves here, the blue curves indicate the accuracy, and the orange curves indicate the validation accuracy for the three different uh, modules. Evaluation matrix analysis that involves strength and weakness of these various metrics. For recall is just a measure of proportion of actual positives cases that actually were identified by the module. And for its strength, or the strength of this is very useful when missing positive cases is a risk to maybe to maybe is a very great risk. And its weakness is basically that may lead to higher number of false positives. And for precision, precision refers to the measure of proportion of positive predictions uh, that are correct out of all predictions. And its strength is very useful when it comes to instances where false positives are very costly. For example, maybe in case of COVID diagnosis, false positive may lead to unnecessary hospitalization, or maybe even quarantine a person who has been maybe who's not even positive. And its weakness maybe is that it's not able to capture all the true positive cases because of too much focus on or because too much focus on precision may lead to model to miss out such to miss out on this on that. And when it comes for accuracy, this is just the measure of overall performance of correct prediction involving both the uh, true positives and true negatives uh, made by the module. And the strength is that it's very simple to understand it, and it reflects generally the performance of the module. And its weakness is that it doesn't consider the balance between true positives and true negatives. And in most cases of an imbalanced data set, the module can acquire high accuracy for simply predicting everything as negative. Uh, the other concept is cross-cups dataset validation. vision transformer. Cross-corpus basically means using one data set for particularly training the module and using another data set for testing it. And for this case here, for instance, when a Brazilian data set was used for training and and for testing a has dataset was used. This is how the module performed, and we saw that the performance declined greatly when the train when the has dataset has 19 dataset was used for training and then the Brazilian dataset for testing. Yeah, and this could be because of the variation in images between the two datasets. And lastly, we saw that they found out like they tried to test the has 19 dataset with COVID XCT for dataset for testing, and that's how it maybe the accuracy kind of improved here. And lastly, this table below shows different performances of different modules on various datasets. Basically, the binary dataset, which is the Brazilian dataset, and the multi-class dataset, which is the has 19 dataset. And this we can see that here the CNN module performed greatly when it performed greatly with the has 19 dataset and relatively lower with the Brazilian dataset. And for the ensemble module, it performed relatively okay. It performed better on the Brazilian dataset and poor still on the has 19 dataset. And but the best module that performed got the best accuracy is the proposed VIT based approach, which is the vision transformer. It got a high accuracy compared to the rest of the modules.